Objective 4, construct a box plot. So this is what our box plot should look like. Okay, at the bottom here you should see a number line, which is considered the units. At the top we have the title. Now if we look inside here, this box plot, okay, over here we have Q1, which is quartile 1, Q2 is the median, and then Q3. And then we also have LW, which is the very edge of this box plot, which is the smallest number, but it's not an outlier. And then over here we have RW, which is the largest number that's not an outlier. And then what we have is LF and UF. Remember, that means lower fence and upper fence. And then the outsides, you can see, are the asterisks. Those represent the outliers. So where those are numbers that are outside of the data. So this is what our box plot should look like when we construct it. This is the information that we need. Now let's take a look at a scenario here. So here is a frequency histogram, and then here is the box plot for that frequency histogram. Same thing in the middle. This is our frequency histogram, and then below that is the box plot for that. Over here is our frequency histogram, and then here's the box plot. Now, when you see the box plot, here you can see that what's highlighted is the right whisker, and that's what we call it. So if the right whisker is substantially longer than the left whisker, then the distribution is skewed right. And you can see that the distribution is skewed right according to our histogram. Over here in the middle, if the left and the right whisker are relatively equal in length, then we can say that the distribution is roughly symmetric. And so this would give us the bell curve here. And then the last one over here on the far right, we can see that here's the left whisker. So if the left whisker is substantially longer than the right whisker, then we can say that the distribution is skewed left. Okay, now, for example, the following data represents the percentages of divorces in 1996 for select countries. We want to construct a box plot for the data. Now, we've already done this in the previous video, but we can break down what is our quartile 1, which we know is 53. Quartile 2 was 64. Quartile 3 was 66. The left fence, or the lower fence, excuse me, is 33.5. The upper fence is 85.5. We have outliers, which are equal to 5 and 6. And we know that the smallest number that's not an outlier is 53. And the smallest number on the right is 68. So here's our box plot. What you can see here is that we have this box. Okay, and then let's take a look at these values here. So we can determine that first we have our number line. So our number line goes in increments from 0 to 90. So we go from 0, 10, 20, 30, 40, 50, 60, 70, and 80, and 90. Now the first thing we want to do is look at quartile 2, which is 64. So in between 60 and 70 is 65. So therefore here would be 64. So here is our quartile 2. And then from there, we're then going to graph quartile 1 and quartile 3. Well, quartile 1 is at 53. So there's quartile 1. And then 66 represents quartile 3. So now we have our box. Now we need to find out our LW, which is our lowest number that's in the data set, and RW, which is the largest number that's in the data set. So we can see here that 68 represents the RW, and 53 is the lowest number in our data set, which is also quartile 1. So therefore you can see here that this also represents the lowest number in our data set. Now we also need to figure out what is our lower fence and upper fence number. Well, if you look down here at the bottom, here is between 30 and 40, and so 33.5 is going to represent the lower fence. And then on the right-hand side, the upper fence is 85.5, so that's right in the middle and a little bit above, so it's 85.5, and therefore that is our upper fence. And so then we also have outliers, which are 5 and 6. So therefore you have your asterisks, and there are your outliers. And then don't forget that we want to write down the title of this box plot, which is divorce rates, and underneath that is percent. And we can see here that it's skewed right because this tail on the right side is longer than the left tail, and therefore it is skewed right. Let's take a look at another example. The mean prices in dollars of regular gasoline in the 50 states in April 27, 2014 are described by the box plot below. So if we look at the box plot, we can see here that this represents 25% of the data, this is 25% of the data, here's 25%, and here's 25%. Here are considered our outliers, and this number would represent the highest. So in part A, it says estimate the mean price of the regular gasoline in Hawaii, which has the highest mean price of the 50 states. So if we take a look at the highest number in our data set, here's the highest number, so that means it's this part here, and then if we go down, it gives us approximately $4.30, and again, we're estimating there. Part B, what percentage of states have a mean regular gasoline price that is at least $3.76? And again, that is more than $3.76. Well, at this point here, this represents quartile 3, which is 3.76. So anything more than that is going to be 25% of the data, because from here to 3.76, since this is quartile 3, that represents 75% of the data, and everything above it is going to be 25%. So therefore, this 25% is the percentage of states where the mean regular gas price is at least $3.75. Part C, it says, what percentage of states have a mean regular gasoline price that is less than $3.76? So that means anything that's less than that is going to be 25% here, 25% here, and 25% here. So if we add that 25% together, we get 75% of states that have a mean regular gasoline price that is less than $3.76. In Part D, it says, estimate the number of states that have the mean regular gasoline prices between $3.48 and $3.76. So here's $3.48, which is quartile 2. And over here, this is quartile 1. And this is quartile 3, which is $3.76. And we want to find out what is the number that would be in between this value. Well, this represents 50% of the data. So 50% is the same thing as 0.50. And we're talking about the states. So 50% of 50 is equal to 25 states. Next question. It says estimate the 75th percentile, which is the left. So again, let's just identify what represents our quartile. So we know that this is quartile 3, this is quartile 2, this is quartile 1, this is our lowest number, this is our greatest number here. And then these represent our outliers. Okay, well, remember that quartile 3 represents 75%. So $3.76 is the number that represents the 75th percentile. Next question says, estimate the percentile of $3.62. Well, $3.62 would be somewhere right here in the middle. Okay, and what can we say about that? Well, that's going to be right at the 50% mark. So it's going to be the 50th percentile.